Hi guys, I'm Jeffrey. So today I'm a math tutor here in Taiwan. So I'll be tutoring math today on the topic of rational functions. So rational functions are just polynomials in fractions, right? So you can see here are some examples of rational expression. So you can see the definition. A polynomial is an expression that consists of sum of terms containing integer powers of x, like 3x to the power of 2 minus 6x minus 1. Okay? But here are some rational expressions. So like I said, there are polynomials, but in fractions, upstairs and downstairs, right? Numerator and denominator. You have polynomials upstairs and you have polynomials downstairs, okay? You can factor them. So if you're not familiar with the topics of factoring, then I encourage you to go back and familiar with yourself with those topics, okay? And for now, you can see you can factor the numerator, and you also can factor the denominator. For this one, it's going to be 2 and 2, right? X to the minus 2 and square. Okay. So for any undefined values, what makes a value undefined? Well, it's going to be something divided by 0, right? Something divided by 0 is always undefined. So you're going to plug in numbers just like with regular functions, right? Rational functions are type of functions. Just like regular functions, you can, in fact, plug in any numbers you want and find out a specific value for that point, right? If it's f of x, if it's gonna be 1, you're looking at the 1, right? Like on the axis, on the plane, you plug in 1. That means you're finding the value when x is 1 and y corresponds to which number on the graph, right? But for now, we're doing like domain. So what would that be? That will be the axis, right? Not y. Y is range, right? So we're finding domain for the rational functions, okay? So for this domain, what will you say about this domain? They are all real numbers except for what? Except for the numbers that make this undefined, right? So 3 is going to make this the whole rational function undefined, and negative 4 as well, right? You make this rational function undefined. So we can test out our understanding. So this will be 7, right? 7 will make this undefined because this will make the denominator 0. And how about this one? Negative 1 over half, right? 1/2, right? So this will be this one. And how about this one? This rational function has two answers, right? Because 0 makes this undefined and negative 1 as well. So it has two answers. And how about this one? This is testing your what? Your factoring skills, right? So you're gonna in fact factor this one first. So it's gonna be 4 and 2, and you're gonna put your negative on your 4 because you want to make the middle part negative 2. So x minus 2 and x plus 2, right? So in fact there are two answers. One is 4 and the other one is negative 2. Okay, so for this one, we all know if x to the power of 2 or x squared plus 4 equals to 0, and if you move the 4 to the other side, it's going to be negative 4. And any number that's squared cannot be negative, right? Unless you're talking about complex numbers, which are the other type of realm. But for now, we are talking about real numbers, and no real numbers can do that, right? So all real numbers will make this whole rational function real, right? Okay, that's for domain. Now let's look at some rational expressions. Okay, so we have a rational expression here. We have x to the power of 2 plus 6x plus 5, okay? Now, can you factor these two? So this will be 5 and 1. That will exactly make this 6, right? And 2 and 1, and you put your negative on 2 because you want to make a negative 1 in the middle. So when you factor both numerator and denominator, you'll find yourself in a place where there's x plus 5 times x plus 1 for numerator and x minus 2 times x plus 1. So what do you see? You can cancel out the x plus 1. But don't forget, that doesn't change the fact that x equals to negative 1 still makes this rational function undefined, right? When you plug in negative 1 into your numerator originally here, right, this will become 1, and this will become what? Negative 1. So this will plus 1. 1 plus 1 equals 2. 2 minus 2 will still make this denominator 0. So it will become undefined, right? So that doesn't change the fact whenever you cancel out a factor terms, you cannot change the fact that it is still a term that give us the clue that will define our domain, right? So in this case will be x cannot be negative 1, right? Okay, so let's move on to, let me see if there's another example. Okay, here, so x to the power of 2 minus 9 and divided by 5x plus 15. So you factor out the 5, that will left you with x plus 3, right? And upstairs, whenever you see this, you're gonna be this will be built in to one of your skills where you can just know that whenever it's square, something square minus something square, it will become x plus 3, and the other term will be x minus 3. So this can be squared. Well, I should say this can be square rooted. So 9 can be square rooted. What if this is like 25? 25 can still be square rooted. So that will become x plus 5 and x minus 5, right? But in this case, we can cancel out the x plus 3 term. And then we cancel out the numerator and denominator. But that doesn't change the fact what? You see here? That doesn't change the fact that x cannot be negative 3. That will make this whole term undefined. You can check that by just simply plug in the negative 3 here. Okay, that will make the denominator 0. Okay, but when you factor, or when you cancel out the x plus 3, you'll make this the lowest term, which is x, lowest expression, which is x minus 3 divided by 5, which is much cleaner. Okay, so let's move on to the other video. Okay, so it is reviewing what we just said. Okay, so what about this one right here? When you factor out the x, or x to the power of 2, which you can cancel out the x, or x to the x squared, x cubed, doesn't matter, but the fact is that you have a what? X cannot be 0, right? Right here. You have a domain where it's going to be all the real numbers, but except for x cannot be 0. And for this case, x also cannot be negative 5, right? Okay. So these are all the definition. Let's check our understanding. Okay, so you're gonna factor out what here? You're gonna factor out 2. Okay, you'll end up with 3x plus 10 and x plus 5. Okay, so here is your simplest term. And here you factor out the x to the x squared, and you end up with x minus 3. And you're gonna have, well, again, x and 4x minus 5. So let me type it here. So you have 2x, well, x squared upstairs and x underneath it. So you're gonna cancel out an x, right? So upstairs will be x minus 3 divided by what? X 4x minus 5, and x cannot be 0, right? I know that the x cannot also be 4 out of 5, but you cannot type in 2 answers. And I think this topic is stressing on the point that even though you cancel out the x, or x minus something, x plus something, you cancel out the terms, you cannot change the fact that, you cannot ignore the fact that the thing that you canceled out give us the clue that for the domain, right? So in this situation with this question, it's gonna be x cannot be 0, right? Okay, so x cannot also be what? 5 over 4, right? Okay, factor this and you get this, and you cancel out the x plus 3, but you cannot change the fact that x cannot be -3. And you will later learn this, that whenever you cancel out, this is called remove, right? Remove. So our term for this in our graph is called removable, right? Because you remove them. It's called removable discontinuity. Okay, discontinuity. Okay. And so check our understanding, 2 and 1, and they're gonna be both negative because your middle part is negative. So x minus 2, x minus 1, and you have an x minus 1 and x plus 1 for your denominator. So therefore you're gonna remove x minus 1, right? You're left with excuse me, x minus 2 and divided by x plus 1, and doesn't change the fact that your x cannot be 1 because x minus 1 equals to 0. Therefore your x cannot be 1, right? Okay, so this one right here is going to be 3 and 5, right? And your negative will be on your 5 to make this -2. Okay, x plus 3 and x minus 5, and this will be x plus 3, x minus 2, right? So you remove the x plus 3, you're left with what? X plus 2 minus 5 for your numerator, and x minus 2 for your denominator, right? Oh, let's just do it on paper. Let's not be smart about this. Upstairs will be -5, right? and plus 3, and denominator will be x plus 3, x minus 2, oh, your x is actually what? Your x cannot be negative 3, right? Negative 3. Okay, check again. Correct. Okay. So that concluded our we're just introducing, for lesson 1, we're just introducing and try to find the domain for rational functions. So you kind of get an idea that it's kind of like functions, but it's gonna be looking real weird on what? It's gonna be real weird on graphing. It's gonna be a little bit different, right? I don't want graffiti decimals. Here, decimals. Okay, whatever. This, okay. So x plus 3 times what? Times x minus 5 divided by what? X plus 3 x minus 2. So the graph will be unique. I should say unique, right? And it has intercepts on here. You can test out the intercepts because the intercepts will just be what? The x-intercepts will be whenever the numerator will be 0, right? So if you plug in the 5, this will make the y 0. So y is equals to 0 will be x-axis, right? So that test out. How about our discontinuity here? I don't see. Oh, there's a negative 3. Negative 3 supposedly to be, I guess the decimal doesn't show, but in reality you have a haloed out dot here, right? Where this will not be defined, right? Negative 3. Okay. So for now, let's close this. Okay, let's conclude our answer, and we'll see you in the next lesson. And good luck on your test and have a good day. Okay, thanks for watching.